Very good evening. In this video, we will try to understand some of the fundamental concepts related to liquation cracking. So we have seen in the video related to welding defects, crack is one of the major defect with respect to weld. In crack, we have seen mainly three categories like hot crack, cold crack, and lamellar tearing. In hot crack, we have seen two types of cracks. One is solidification crack, another one is liquation crack. So about solidification crack, we have understood the mechanisms as well as the factors that should be that are responsible for solidification crack. In the last video, we will do the same thing for liquation crack in this video. So basically, liquation crack occurs in the partially melted zone of the weld. So what is basically partially melted zone? We have already seen in the fundamental videos related to welding. There are three major regions with respect to weld. One is the fully melted fusion zone. Adjacent to that, we have this heat affected zone on both the sides. So, and partially melted zone will be somewhere this region, which is nothing but it is a transition region between 100% melted fusion zone and 100% solid region. 100% solid region, which is nothing but the HIZ. So this is what we call it as partially melted zone. Okay. So this liquation crack occurs mainly in the partially melting zone of the weld. So next we will understand what causes a liquation crack. Liquation crack is mainly due to the localized melting along partially melted zone as well as HIZ grain boundaries. So this localized melting is the major reason for the formation of liquation crack in any weld. So the size of the crack will be usually 2 to 3 grain diameter size, and it usually extends into the HIZ. So if you see any crack near the partially melted zone, and if it is extending inside the HIZ, then we can get an idea. We can understand that it is liquation crack, and it is usually intergranular. So intergranular, we know. So we have lot of grains in the material. So this crack will go along the grain boundaries. So like this. So along the grain boundaries, this crack will propagate. That's why we call it as intergranular. So we'll try to see some of the pictures related to liquation crack. These pictures were taken from Welding Metallurgy and Weldability book by John C. Lippold. So this is a classic example of liquation crack which was noted in nickel based alloy, that is 718. You can see this arrow mark shows the fusion zone, and this is the area where we are seeing this liquation crack. As you can see, the size of the crack is like 2 to 3 grain diameter size, and it is intergranular. It is going along the grain boundary. So this is one of the examples for liquation crack which occurred in Inconel 718. And we'll see what happens exactly which during the welding process which might lead to liquation cracking. So I'll try to draw the diagram of these zones, different zones. So I have drawn the three zones of the well, that is fusion zone, partially heat affected zone on both the sides, and unaffected base metal. And we have just now seen that what is partially melted zone. I have enlarged the partial melted zone here. So what happens during welding is that since the partially melted zone is weakened by the localized grain boundary liquation, it cracks due to the pulling caused by the solidifying weld metal. So during solidification, what happens is this solidifying metal pulls this area. Since the grain boundary is already weakened by the presence of liquid films, it results in the formation of cracks along the grain boundary. So this is what happens during fusion welding process, which might lead to the formation of liquation crack. So there are generally two mechanisms that are responsible for the formation of liquation crack. First one is penetration mechanism. Second one is segregation mechanism. So we'll try to understand both the mechanisms by which this liquation cracks occurs in any metal, any alloy. Okay. So first we will understand this penetration mechanisms. So the penetration mechanism for this liquation crack requires both liquation and grain boundary motion. Liquation and grain boundary motion. This liquation and grain boundary motion should happen simultaneously. You can see it in the above picture here. Already some liquation has happened in the partially melted zone. This is the partially melted zone. This area's right side is partially melted zone. This is the interface, and you can see grains are growing in this direction. So liquation has already started, and we have a mobile grain boundary. So when the two things happen simultaneously, the boundary will reach the liquidated region, which will result in pinning, and at the same time it will inhibit the further motion of the grain boundary. So this is the second step. First step, liquation, as well as we have a mobile grain boundary. When these two touch or encounter each other, this pinning as well as because of the pinning, further motion of this grain boundary will be prevented. Depending upon the wetting nature of this liquid boundary combination, the liquid will penetrate into the grain boundary and it will form liquid films as shown in the third figure. So first thing we have seen is liquation, grain boundary motion. Then motion of the grain boundary will be stopped because of the encounter that happens between the liquidated particle as well as the grain boundary, and we finally see wetting leading to penetration of the liquid particle into the grain boundary, and at the end we will be having a complete liquid film. So first question is that how this liquation generally happens. So that is because of incipient melting. The reason for the liquation in any material may be due to this incipient melting. So it generally occurs at grain boundaries of any material, since these grain boundaries are generally at high energy states. It occurs at a temperature around solidus temperature of the material. So depending upon the presence of impurity also, the liquation temperature may change, but generally it occurs within a few degrees of solidus temperature of a particular material. So this is what this penetration mechanism discusses with respect to the formation of liquation crack. So basically we have seen that it involves three steps: liquation, grain boundary motion, as well as wetting and penetration. So liquation and grain boundary motion should happen simultaneously when this liquidate particle encounter this grain boundary. it will pin the motion of the grain boundary, and at the same time wetting of the grain boundary happens. If depending upon the wetting characteristics, we will get a liquid film like this. So the reason for the liquation, it is due to the incipient melting, which usually happens at a temperature or of around solidus temperature of a particular material. It occurs at the grain boundary, since these grain boundaries are generally at high energy states. Okay, so this is what penetration mechanisms discusses with respect to liquation cracking. So next we will see the second mechanism with respect to liquation cracking, that is segregation mechanism. So segregation mechanisms, it is mainly due to the presence of impurity atoms, impurity elements like sulfur, phosphorus along the grain boundary of the partially melted zone. So when the temperature is increased, these impurity atoms melts and it leads to the formation of liquid film. So when during the solidification, since this solidifying area pulls the partially melted zone towards the right side, that is towards the fusion zone, this liquid film weakens, leading to the formation of cracks. That is what we have seen in the beginning also. Just remember this step. So there will be a pull due to the contraction of the fusion zone during solidification. Since the liquid films are present along the grain boundary, it leads to the formation of crack. Okay, so this is what segregation mechanism tells about the formation of liquation crack with respect to any material. And this liquation crack, whether it is possible to occur in fusion zone of the weld, if we see it is if we see whether it is possible for the liquation crack to occur in a fusion zone, it is possible only when in the multi-pass wells. In the multi-pass wells, same phenomena which we have discussed before may happen in the multi-pass wells. Since we join the thicker plates by multiple passes, in those kind of wells, there is a possibility for the liquation crack to occur even in the fusion zone of the weld. But if it is a single pass weld, it will only occur in the partially melted zone of the weld. Next we will try to understand what are the factors that will promote the formation of a liquation crack in any material. First important factor is composition. Composition. Since alloys contain different metals and they are added intentionally to promote certain properties, these alloy metals will have a role in formation of the liquation crack. For example, in inconel 708, niobium is added to get certain properties, but this niobium will react with certain certain elements of metal alloy to form MC type carbides, which are generally susceptible to liquation in the HIZ. So if any element which has the capability to form MC type carbides, then there is a possibility for the formation of liquation crack. And generally these MC type precipitates are formed, carbides are generally formed due to the presence of niobium as well as titanium. These alloying elements, that is niobium and titanium, may be added to get certain properties in the material, but because of their affinity to carbon, they may react to form MC type carbides, which generally leads to liquation in the HIZ. So composition will play an important role with respect to the formation of liquation cracking. And other impurity elements in steel and nickel based alloys are phosphorus and sulfur, as we have seen in the segregation mechanism. And in some cases boron is added intentionally to promote better creep resistance. So the presence of boron also may lead to the formation of liquation crack, but it is not possible to avoid them completely because we need certain properties in that material. So first factor is the composition, second factor is the grain size. So if the grain size is finer, we have large grain boundary area, if the grain boundary area is more, even if some liquid films are present, since because of the even some liquid films are present, even though grain boundary area is large, it will prevent strain localization as well as potential cracking and cracking. So it is generally recommended to carry out welding in such a way that it has fine grains, since fine grains will have larger grain boundary area. If larger grain boundary area is present, even if there is little liquids in the grain boundary area, this will prevent the strain localization, which in turn prevents the formation of the crack. Whereas on the other side, if the grain size is high, the grain boundary area decreases. So if the liquid is present along the grain boundaries, it will be more susceptible to the cracking, since the strain will be localized, and it will lead to the formation of the crack. Okay, so we have to do welding in such a way that the grain size is finer. For example, there is a graph which shows the relation of crack susceptibility and the grain size. So crack susceptibility is taken in the y-axis and grain diameter in the x-axis. So this is the trend. So even if you have high impurity, if the grain size is less, you can see the crack susceptibility is comparatively lesser at higher impurity. Whereas if the grain size is high, the crack susceptibility is more. So this is for high impurity situation. This lower one is for low impurity situation. Okay, so grain diameter, grain size will directly have an influence on the liquation crack. It is recommended to weld in such a way that it results in the formation of fine grains. And there is another relation with respect to the crack length and grain size. Grain size taken in the x-axis and the crack length in the y-axis. So this is how it goes. Grain size, if it is lower, the crack length is lesser. This is observed in two kind of materials, one with high boron content, another with low boron content. The one which is seen in the top is related to high boron content alloy. You can see the grain size has a role with respect to the crack length. At a lower grain size, the crack length is lesser. At a higher grain size, the crack length is more. Similar trend was seen in a low boron content alloys also. And then another important factor which has a role with respect to liquation cracking is heat input. So since HIZ and metal liquation cracking happens over a particular temperature range, the amount of heat that we are supplying will have a greater influence on the formation of the liquation crack. Generally, lower heat input weld can reduce the grain boundary melting in the HIZ. So it is always recommended to weld with lower heat input. Lower heat input will lead to the result. Lower heat input will lead to the less chances for liquation cracking. Next factor is filler material strength. So lower strength filler metals, it will result in less shrinkage stress. If there is a less shrinkage stress, it will lead to less chance for liquation crack. So as we have seen in the initial portion of the video, we know that during solidification there will be a pull towards the fusion zone by the solidifying weld metal. If the filler metal strength is less, the amount of pull will be comparatively lesser. So the possibility for the formation of the crack due to the presence of liquid film in the grain boundaries of the partially melted zone will be comparatively lesser. Okay. So this is the fourth factor with respect to the liquation cracking. And finally we will conclude this video by seeing some of the steps to prevent the liquation cracking. So generally we have to follow all the steps that we have followed with respect to solidification cracking. So in the last video we have discussed some of the steps that have to be followed to prevent the solidification crack. The same thing can be followed for the prevention of liquation cracking. So that is main thing is minimize the impurity content. Impurity content should be minimized as much as possible. Then fully austenitic structures is also not recommended. Fully austenitic structure not recommended. Some ferrite presence will help us to prevent the liquation cracking, as we have seen in the solidification cracking, since it has the capability to absorb the impurity atoms like sulfur and phosphorus. And then the presence of low energy special grain boundaries. Low energy grain boundaries has been successful in preventing the formation of liquid films. So we have to carry out welding in such a way that there is more low energy special grain boundaries, so that the liquation crack will be prevented. And we have to minimize the amount of titanium and niobium element in the material, but it is not possible in all the cases, since it is intentionally added to promote certain properties in that particular material. So these are all some of the steps that we can take, along with the other steps which we have discussed in the solidification crack prevention. So to summarize, we have seen what is a liquation crack, what is the location at which liquation crack occurs, and we have seen it is intergranular. It occurs in the partially melted zone of the weld, and we have seen two mechanisms with respect to the liquation crack. One is penetration mechanism, second one is segregation mechanism, and we have seen what are the factors that will be resulting in the formation of liquation crack. In that we have seen four factors: composition, grain size, filler strength, as well as heat input. And then we have discussed at the end what are the steps that we have to generally take to prevent the formation of liquation crack. It is almost same as we have seen in the solidification crack. Okay, so thanks for watching.